So now we'll see the general and normal form of the equation of the plane. So before that we'll see what is meant by a plane. Okay, so what is meant by a plane? So that first we will see. A plane is nothing but a surface. See, a surface f of x, y, z is called a plane. If given any 2 points on this surface, okay, the straight line, that means the segment joining them also lies wholly on that surface. So that means what? Suppose this is a surface. Okay, so take any 2 points. This is what P1 and this is P2. So this is what P1 and P2. Any 2 points on the surface. The segment joining P1 and P2. The segment joining P1 and P2 also lies wholly on that surface. Then that surface is called a plane. So if you this is a circle, then this is a plane. Suppose if you draw the circle like this, okay. Suppose this is your surface. Is it a plane? So now see, if I take the point P1 here, if I take the point P2 here, and if I join this, so see the segment do not lie on the surface. The whole segment do not lie on the surface. This point is outside the surface. So this is not a plane. Not plane. Okay. So this is a plane now. Any 2 points. Take any 2 points wherever you want. Okay. So that segment lies wholly in that surface. Then such a surface is called a okay. So if you say this is what like this. Suppose this is a polygon. Like this. Is it a surface? No. Is it a plane? No, this is not a plane. If you draw this like this, okay. So this is not a surface now. This is not a plane. Okay. So that means if you consider the circle, triangle, quadrilateral, okay, circle, these are the plane now. You take any 2 point here, okay. So, now if you like this, such like of this surface, this is the surface. This is a plane. This is the plane. This is a plane. This is not a plane. This is not a plane. Okay. So note that this. Okay. So that means what here? Triangle is a plane. Circle is a plane. Okay. So what about the ellipse? If you take the ellipse now here. Okay. So for ellipse. Now take any 2 points here now. Take any 2 points everywhere. So that ellipse is also a plane. Ellipse is also interior part of the ellipse is a plane. Okay. So note that. So I hope that you understand what is meant by a plane now. Okay. So plane is a surface. Right? Such way that the segment joining any 2 points it lies wholly in that surface. Then such a surface is called a plane. Okay. So now, when this is made now, general equation of first degree in x, y, z. So we'll see the theorem now. See the theorem. Okay. Every equation of first degree in x, y, z represent a plane. Okay. So prove. The first degree equation in x, y, z is of the form ax plus by plus cz plus d is equal to 0. So what is our aim? We want to prove that equation 1 represent a plane. Okay, represent a plane. Okay, so let P x1 y1 z1 and P q will say q x2 y2 z2 be any 2 points on the surface 1. Okay, so now P1 P x1 y1 z1 q x2 y2 z2 are the points on the surface. That is what they satisfy the equation of the surface. Okay, so therefore we have ax1 ax1 not a1 now, ax1 plus by1 plus cz1 plus d is equal to, I call this as 2 now, ax2 plus by2 plus cz2 plus d is equal to, this is 3. Because what here, they lie on the plane, because they are points on the plane, that means they satisfy the equation of the plane. What is our aim? We want to prove that equation 1 represents a plane. That means these any two points we have taken. Okay, so what we have to do? The segment joining any 2 points, that means this is P and Q. Okay, segment joining any 2 points or lie on the surface 1. That means every point on the segment, every point of the segment satisfy the equation 1. This we want to prove. Okay, so suppose R is the any point on the segment PQ. So R is the any point on the segment PQ. That means what here, R divide the segment PQ in the ratio, internally in the ratio some k is to 1. Okay, so let R be the point, R be the point on segment PQ, So therefore R divides segment PQ internally in the ratio k is to 1 seg. Then by section formula, yesterday in the last video lecture we have seen the section formula. Okay, so by section formula we have, so what here, segment PQ, R divides the segment PQ internally in the ratio k is to 1. Okay, so therefore coordinates of R we get. What here? You have to multiply by k to q. Q is your x2, y2, z2. Okay, so k x2 plus 1 x1 upon k plus 1. Okay, so k y2 plus y1 upon k plus 1. K z2 plus z1 upon k plus 1. Okay, so for this R, LHS of 1. Okay, so A into kx2 plus x1 upon k plus 1 plus B ky2 plus y1 upon k plus 1 plus C kz2 plus z1 upon k plus 1 plus D. Okay, so what I will do, I will take 1 upon k plus 1 common, and what happened here, k x2 plus x1 plus b ky2 plus y1 plus c kz2 plus z1 plus d. I have taken k plus 1 common, that means I have to multiply this d. So your d is what, d into k plus 1 upon k plus 1. So therefore we have taken k plus 1 common now here. So this is what then, 1 upon k plus 1. So I will collect the first term now here. What? A k, b k here, k k. I will collect the term of the k now here. So I will collect the term of k now. K into what here? Ax2 plus by2 plus cz2 plus d now. Plus d. Okay. Now I will collect all the terms which do not contain k. So this is what then, ax1 plus by1 plus cz1 plus d. So this is what then, 1 upon k plus 1. So this is k into 0. This is 0 again. Since by 2 and 3. From 2 this is 0. And from 3 this is, okay, from 2 this is 0. And from this is 0. Okay. So this is what then, 0. This is what 0. And this is what the RHS of 1. RHS of 1. So what? For any value of k. So no matter the value of k here. No matter the value of k here. So for any value of k, therefore, for any value of k, R satisfies equation 1. Okay. So if you change the value of k, we get a different point of this. Okay. So therefore any point on segment PQ satisfies equation 1. Therefore segment PQ lies on surface 1, right? So that means what? P and Q are arbitrary and segment PQ is also arbitrary. So that means what? Segment PQ lies on the surface 1. Therefore surface 1 represent equation of a plane. Equation of a plane. So thus equation 1 represent plane. So first degree equation in XYZ represent a plane. So this is the problem. Okay. So we have proved this. We write note 1. Equation of a plane parallel to XOY plane is Z is equal to some C. Z is equal to C. Okay, plus or minus C, whatever it is, no problem for this one. Okay, so the equation of a plane parallel to XOZ plane is y is not there, so y is equal to b. Okay, so third equation of a plane parallel to YOZ plane is x is equal to a. So next, for equation of XOY plane is z is equal to 0. Because on XY plane, everywhere your z coordinate is 0. Okay, so 5. Equation of XOZ plane is y is equal to 0. And 6. Equation of YOZ plane is YOZ means what? A plane which contains y axis and z axis. Okay, so its x is not there, that means x is 0. Okay, so this is the note. We'll take a problem. Does the point 2 minus 1 2 lies on the plane twice x plus y minus z is equal to 3. Okay, solution. Given that equation of a plane is twice x plus y minus z is equal to 3. Okay, so for we'll write this p 2 minus 1 2 NH, we'll call this as 1. Okay, so NHS of 1 is equal to 2 into 2 plus minus 1 minus 2 minus 2. So this is equal to what? 4 minus 1 minus 2. So this is what 1. This is not equal to RHS of 1. This is not equal to RHS of 1. So therefore P 2 minus 1 2 do not satisfies the do not satisfy do not lies on, that we write do not lies on, because our problem is what we have to check whether it is lies on the plane. Do not lies on the given plane. Okay. Find next problem. Find the coordinates. Find the coordinates of the points where the plane x plus by plus cz plus d is equal to 0 meets the three coordinates axis, with the coordinate axis. Okay, solution. Given that equation of plane is ax plus by plus cz plus d is equal to 0. Okay, I call this as 1. So what I want to find? I want to find this plane intersect to the x-axis, y-axis, z-axis. So I want to find the coordinates of a point where this plane comes to the x-axis. Okay. So on x-axis, y is equal to 0, z is equal to 0. So one implies that ax plus d is equal to 0. So x is equal to minus d upon a. Okay. So therefore plane and the coordinate cuts the x-axis at minus d upon a 0 0, or the point of intersection of the x-axis and the plane is this. Okay, you may write it. On y-axis x is equal to 0, z is equal to 0. So one implies that x is equal to 0, z is equal to 0. So this is what by plus d is equal to 0, implies that y is equal to minus d upon b. Okay. So therefore plane cuts the x-axis here, y-axis at 0 minus d upon b 0. Okay. Similarly, plane cuts the z-axis at 0 0 minus d upon c. Okay. So the problem is over now here. Now the normal form we'll see. Normal form of equation of a plane. Okay. So we'll write the theorem. If p is the small p, okay, this is the small p. If small p is the length of the perpendicular from the origin to a plane to a plane, and LMN, the direction cosines of that perpendicular, of that perpendicular, then the equation of the plane is Lx plus My plus Nz is equal to P. Okay, so prove. So suppose we'll draw the figure so that you will understand this one. Suppose this is your x-axis, suppose this is y-axis, 0, this is z-axis. Okay, now suppose this is a plane now, whose equation we need. This is a plane whose equation we want. Okay, let n be the point on the plane. So this is what ON. So this length is P. Okay, let n be the point on the plane, such that ON is perpendicular to the plane. Okay, so it is perpendicular. What do I do? P is the length of the perpendicular from this one. Okay, so P and ON, your ON is what? Small p, and LMN are DCS of ON. Element are the DCS of ON. So we have the direction cosines of this one. Okay, so now I will take here P is any point on the plane. Okay, let okay, so then coordinates of n will be so this is your PL. Okay, PL, PM, PN. Okay, so this is your P now. PM, PN, PM, PN are the coordinates of P. Okay. Okay, so let P be PXYZ. Let PXYZ be any point on the plane. Okay, we want to find the equation of the plane. Okay, so that means we have to find a relation among x, y, z. Let P, x, y, z any point. Now apply the geometrical condition. So what is it? Okay, so we'll find first DRS of NPR. DRS of NPR. Right? X minus, you have the coordinates of P and you have the coordinates of N. So x minus Pn, x minus Pm, y minus z minus Pn. Okay, as this. Okay, but now NP lies on the plane, because N is the point on the plane, P is also the point on the plane. So by definition of the plane, the segment NP lies on the plane, and ON is perpendicular to the plane. ON is perpendicular to the plane. If line ON is perpendicular to the plane, then any line on the plane is also perpendicular to ON. So therefore ON is perpendicular to NP. So you have the DRS of ON. So DRS of ON is what? DCS of ON, LMN. So therefore what? Therefore L into x minus PL plus M into y minus PM plus N into z minus Pn is equal to 0 by our definition. Right? So So because they are the perpendicular, we don't need now the figure and all those things. Okay, so our problem is over actually. So what is this? That we'll multiply this. This is Lx minus Pl square plus My minus Pm square plus Nz minus Pn square is equal to 0. So this is what? Lx plus My plus Nz minus, I can take P common. So this is what? L square plus M square plus N square is equal to 0. So this is Lx plus My plus Nz minus P into 1. This is 0. Okay. So Lx plus My plus Nz is equal to P. So this is required equation of plane, and it is called normal form of equation of a plane, and it is called normal form of equation of the plane. So very simple. Just we have just what we have found only the DCS of the DRS of the NP. Note that the DCS are nothing but the DRS. DCS are nothing but the DRS. So we have the DRS of ON and DRS of NP. We had ON is perpendicular to NP. So we know that if they are the perpendicular, then the dot product is 0. So just we have seen this one. Okay. So we got the equation of the plane in the normal form. Okay, so we'll take an example. Find the equation of the plane passing through the point 1 to 1 and perpendicular to the line OP. Find the equation of plane passing through the point OP and perpendicular to the line OP. Okay, solutions. This is P. This P is given to you. Okay. Given that P 1 to 1 is a point on the plane. Okay. OP is perpendicular to the plane. Therefore, OP is normal to the plane. OP is normal to the plane. Okay, so OP is normal to the plane. That means what? You have to find the DCS of the OP, and you have to find the distance between A and P. Okay, you have to find the distance between O and P. You have to find the distance between O and P. Okay. So first we find the DRS of OPR. DRS of just a point is nothing but the DRS of OP. So 1 to 1. Okay. So once we have the DCS, the DRS, you can find the DCS also by dividing the DCS. Okay. DCS of OPR. R. What? 1 upon root 6. 2 upon root 6, 1 upon root 6. Okay, so these are the DCS. Okay, now we will find OP now. OP is what? Root of 1 square plus 2 square plus 1 square. Okay, so this is again the root 6. Okay, so by normal form of the equation of plane, The required equation of plane is the required equation of plane is you have to find the equation of plane is what your Lx is what 1 by root 6x plus 2 by root 6y plus 1 by root 6 z. This is what Lx plus My plus Lz is equal to p. P is your you have to take the positive root. This is 6. You can simplify this now. You may write this is what 1 plus twice y plus 6 is equal to 6. This is the required equation of plane. This is the required equation of plane. Okay, so we'll take the next problem. Fine. We'll write a note from that one. Okay, note for objective that one. The equation of the plane. The equation of the plane passing through PABC and perpendicular to OP is AX plus BY plus CZ is equal to A square plus B square plus C square. Okay, so for objective this note is very important here. And see the last one is what here. These are the coordinates of P, and this is what A square plus B square plus C square, that is 6 here. Okay, we got to this one. From that example you can do this note. Okay, now we'll take the next problem. Find the equation of the plane. Find the equation of the plane containing the lines through the origin with the direction cosine proportional to 1 minus 2 and 2 3 minus 1. Containing the lines through the origin with DCs which are proportional to 1 minus 2 and this. Okay, solution. Let AX, let the required equation of plane be. Let required equation of plane be AX plus BY plus CZ plus D is equal to. We call this as 1. This is our required equation of plane. Okay. The find the equation of line containing the line through the origin. The line passing through origin means the line passing through origin. So therefore the line passing through origin and which is contained in plane. So therefore the plane 1 also passing through origin. So therefore A into 0 plus B into 0 plus C into 0 plus D is equal to 0 implies that D is equal to 0. So you have the value D is equal to 0. What is our aim? To find the values of A, B, C, D. Okay. So the lines which D, C, S are proportional to 1 minus 2 and 2 3. Okay. So therefore the normal to the plane, normal to the plane is perpendicular, okay, is perpendicular to the line, perpendicular to these lines. Then see, so whatever the coefficients of x, y, z are nothing but, so this is your plane suppose, and whatever is normal to the plane, normal is perpendicular to the plane, so DCS of this line is ABC. Okay, so DCS of this coefficient of x, y, z represent the direction ratios of normal to the plane, direction ratios of normal to the plane. And what you have, these are the two lines in the plane, so whose direction ratios are 1 minus 2 like this. Okay, so these are the lines in the plane. That means what, if a line is perpendicular to the plane, then the line is perpendicular to each line of the plane. Okay, so therefore we have what, ABC are the DRS of the normal to the plane. Okay, so we have DRS of normal to the plane are, DRS of normal to the plane are ABC. Okay, so therefore we have, therefore I write here, so this normal is perpendicular to the plane whose direction ratios are this. Okay, so that means what, the dot product is 0. That means what, A minus twice B plus twice C is equal to 0. So twice A plus 3B minus C is equal to 0. We'll write A upon now. A upon what, minus 2, 3, 2, minus 1. Minus B upon coefficient of A now here. So 2 minus C, minus 1, minus 1. C upon 1, 2, minus 2, 3. Okay, so once we got the value of ABC, we get the required equation of the plane now. Okay, so directly we can write the value of A as the denominator now. This is A upon, so this is what, 2 minus 6 is minus 4, minus B upon, so this is 1. Okay, so minus 1 minus 4, this is minus 5. C upon, this is 3, minus minus become plus, so this is 7. Okay, so this is A upon minus 4, B upon 5, C upon 7. So therefore what, 1 implies that your A is minus 4, so minus 4x plus 5y plus 7z is equal to 0. You may change the sign, 4x minus 5y minus 7z is equal to 0 is required equation of a plane. Required equation of a plane. Angle between two planes. Angle between two planes. Let A1x plus B1y plus C1z plus D1 is equal to 0 and A2x plus B2y plus C2z plus D2 is equal to 0. B the two planes. Okay, let theta be the angle between the planes. Okay, so DRS of normal to the planes are A1, B1, C1 and A2, B2, C2. Okay, so theta, the angle between the angle between plane is nothing but the angle between their normals, their normal angle between the plane. So see, suppose you have these two planes. Okay, so whatever this is the angle, and if this is perpendicular to this one, so this angle is same as this angle. Okay, so angle between their normals to the plane. Okay, so therefore cos theta is equal to a1 a2 plus b1 b2 plus c1 c2 upon root of a1 square plus b1 square plus c1 square into root of a2 square plus b2 square plus c2 square. Okay, so therefore theta is equal to this cos inverse of a1 a2 plus b1 b2 plus c1 c2 upon root of a1 square plus b1 square plus c1 square into root of a2 square plus b2 square plus c2 square. Note, the planes are perpendicular to each other. The planes are perpendicular to each other if cos theta is 0. So when cos theta is 0, if denominator is 0 for each other, if and only if a1 a2 plus b1 b2 plus c1 c2 is equal to 0. So again the same thing here, the coefficients of x y z here, right? The dot product of the coefficient of x y z is 0, then the planes are perpendicular to each other. Okay, so this is note 1. Okay, the planes are parallel to each other if and only if a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. Okay, so this is the very important thing here, to find angle between the planes and normal form of this one. So we'll see some problem. Find the DCS with direction cosines of the normal to the plane twice x minus 3y plus 6z is equal to 7. Also find the length of perpendicular from the origin to the plane. Okay, solution. Given that equation of plane is twice x minus 3y plus 6z is equal to 7. We call this as 1. Okay, so DRS of normal to the plane R. The coefficient of x, y, z are nothing but the DRS of the normal to the plane. So that is what? 2 minus 3, 6. What we will do? We will find the sum of the squares of that one. 2 square minus 3 square 6 square. We will find the value of this one. So this is 4 plus 9 plus 36 root 49. This is 7. So therefore DCS of normal to the plane R normal to the plane R 2 by 7 minus 3 by 7 6 by 7. Okay. Now what you want? The perpendicular. Okay. So perpendicular. The length of perpendicular. So that what? How we find this? We have to convert. See here. This is what? Twice x minus 3y plus 6z is equal to 7. We'll divide by 7 now. This is what? 2 by 7x minus 3 by 7y plus 6 7z is equal to 1 now. Right? Now see, these are the d's here. This is what? Lx plus my plus nz is equal to p now. This is p. This is p. Okay. So if this is minus sign, so you have to write this root as a minus 7. Take the negative roots now here. Make this as a positive because this is the length of. Make this is what? If this is minus 7, then change all the sign now here. Change all the sign and I'll take the modulus of that one. Okay. So therefore, the length of the perpendicular. Therefore, just will write here. Therefore, instead of this. Okay. Therefore, the length of the perpendicular to the plane is 1. So this 1 is there. Okay. So the what if this is minus 7 is there? So minus 7 you write just minus 7 here. Just divide by this one. This whatever this. If you get a minus sign here, so change all the sign and write that is 1. Okay. So okay here. Okay. So find the distance of the origin from the plane 6x minus 3y plus 12z minus 14 is equal to 0. Okay, solution. Given that equation of a plane is 6x minus 3y plus 5z is equal to 14. Just highlight this. You have to divide by this 6 upon root of 6 square plus minus 3 square plus 2 square x minus 3 upon root of 6 square minus 3 square plus 2 square. We will convert this in the normal form. Okay. So y plus 2 upon root of 6 square minus 3 square plus 2 square z is equal to 14 upon root of 6 square plus minus 3 square plus 2 square. Okay. So what is that? 6 upon, this is what? 36 plus 4 9. So this is 7 minus 3 by 7y plus 2 by 7z 14 by 2 now. So 14 by 7. So this is what? 6 by 7x minus 3 by 7y plus 2 by 7z is equal to. If you got this negative, then change the sign here. Okay. So therefore, distance of origin. Therefore, the distance of origin from the plane is 2. From the plane is 2. Okay. So the problem is over here. Show that the normals to the planes are x minus y plus z is equal to 7, 3x plus twice y minus z plus 2 is equal to 0 are perpendicular to each other. Okay. Or show that these planes are perpendicular to each other. Okay. Solution. Given that the equations of planes are x minus y plus z is equal to 7. I call this as 1. 3x plus twice y minus z plus 2 is equal to, I call this as 2. Okay. So DRS of normal to the plane 1R 1 minus 1 1. Coefficients of x y z represent the DRS of normal to the plane. Okay. So DRS of normal to the plane 2R 3 2 minus 1 minus 1. So here A1 is equal to 1, B1 is equal to minus 1, C1 is equal to 1. So A2 is equal to 3, B2 is equal to 2, C2 is equal to minus 1. Okay. So we'll find the value of A1 A2 plus B1 B2 plus C1 C2. So your A1 is 1, your 2 is 3, B1 is minus 1, this is 2, your C1 is 1, C2 is minus 1. Okay. So this is 3 minus 2 minus 1, this is 0. Right. So therefore normal to the plane, normal to the given planes are perpendicular to each other, or the planes are perpendicular to each other. Both the things are there. We take one more problem. Find the angle between the planes twice x minus y plus twice z is equal to 3 and 3x plus 6y plus twice z is equal to 4. Okay. Solution. Equation of planes are twice x minus y plus twice z is equal to 3. Call this as 1. 3x plus 6y plus twice z is equal to 4. Call this as 2. Okay. So here A1 is equal to 2, B1 is equal to minus 1, C1 is equal to 2. Okay. A1 A2 A1 B1 C1 from the first plane. From the second plane, A2 is equal to 3, B2 is equal to 6, C2 is equal to 2. Okay. So cos theta is equal to cos theta. Okay. So let theta be the angle between planes, given planes. Okay. So cos theta is equal to A1 A2 plus B1 B2 plus C1 C2. Just write the formula. Root of A1 square plus B1 square plus C1 square into A2 square plus B2 square plus C2 square. Okay. So we write the values of this. A1 is 2, 3 plus minus 1. Along with the sign, you have to write the value 2 into 2. Otherwise, you get the wrong answer. So this is what sum of their squares. So 2 square minus 1 square plus 2 square into 3 square plus 6 square plus 2 square. No one is negative. 2 square. Okay. So cos theta is equal to what? 6 minus 6 plus 4 upon. So this is what? 4 plus 4 is 8 9. So this is 3. So first value is 3. Second value is 7 now. So cos theta is equal to 4 by 21. So theta is equal to cos inverse of 4 by 21. Okay. So keep this value as it is now. Okay. In this way, you can find the angle between any two planes. Okay. Okay, so we'll take the last problem. Transform the equation of the plane x plus twice y plus twice z minus 2 is equal to 0 into normal form. Okay, solution. Given that equation of plane is x plus twice y plus twice z. I'll write this is 2. Okay, so now I'll divide by the sum of the squares of the coefficients of x, y, z, to each term. So this is what? 1 upon root of 1 square plus 2 square plus 2 square. Okay, this is x plus 2 upon 1 square plus 2 square plus 2 square plus 2 upon root of 1 square plus 2 square plus 2 square z is equal to 2 upon root of 1 square plus 2 square plus 2 square. Just write all the things here. So this is 1 by 3. 1 by 3x plus 2 by 3y plus 2 by 3z is equal to 2 by 3. Now see, this is positive. Okay, so this is the required. See, this is what nx plus my plus nz. So n square plus m square plus n square will be 1. These are the DCS. Okay, so this is required normal form. Right? So this should be the positive. Okay, suppose here you have this now. Suppose we have this equation. This is plus sign now here. And you have to express this in the normal form. So this will what then? Minus 2. This will be the minus. This will be the minus. This will be the minus. Then what you have to do? You have to change the sign now. You have to change the sign of minus. That means you have to change all those things. 1 by 3x minus 2 by 3y minus 2 by 3z is equal to 2 by 3. This is the normal form. This is required normal form of the equation of the plane. Okay, you have to make this side as a positive. Do all those things here. If it is negative, then change all the sign only. Okay, if it is not negative, then do not change the sign. Okay, so this is the problem of to convert to normal form. You have to take the care of this side because this is the distance from the origin, and you know that distance is always positive. Okay, so therefore this sign should be the positive. Okay, so actually this you have to take this sign as root of this one. You have to take the root of this one plus or minus now here. It is depending on your d. If your d is negative, then you have to take the negative roots. If your d, whatever this d is here. So I have taken this as x plus by plus cz plus d is equal to 0. Plus d. If d is positive here, then you have to shift that, it will become a negative now here. So that means if d is positive, you have to take the negative root of this one. If d is negative, then you have to take the positive root of this one. Because what this becomes here, this is negative, that means minus is just shifted there with the same sign here. Okay, so your d is here. If d is here, it's like this. If your equation is this, x plus by plus cz is equal to d. If d is positive, you have to take the positive root. If d is negative, you have to take the negative root of this one. So here what your d is negative, therefore I have taken the negative root of this one. Okay, so just change the mind. Don't do that negative and positive all those things. Don't consider. Just consider this in a natural way. Okay, if this is negative, just shift minus. Just multiply by the minus. So make this as a positive now. Make this as a positive. Then it will be the required normal form of the equation of the plane. Okay, so now we'll stop here. Thank you.